antennas. So this is actually looking at some of the patterns, gains, tilts, these types of characteristics. Obviously, you're going to need to input within the station in order to do the antenna modelling for coverage, for example. I'll also cover antenna reference as well. So this is there's a couple of things there which I'll look at in terms of antenna reference. And then the last section of it will be about kind of using the antenna. So if I want to make some changes, whether that's patterns or other information, how do I do that in a batch way to a number of stations? I'll cover the library. So there are actually some antennas that are provided with the tool. So you may not even have to do some of this importing exercise that we're going to cover initially to take you through where they're stored and what types of antenna are available. And then finally, I'll look at a little bit about the antenna object display, and then just run a very quick prediction at the end that obviously takes some of the antennas that we've started with from an import through the configuration, then actually using it in a coverage. Okay, so firstly, importing antennas. So I'm going to look at some of the standard formats. So this is MSI, PLT. There's also other ones, ADF as well. So these are ones that maybe have been provided to you from an antenna manufacturer that contain the antenna data, so details about the antenna pattern, antenna gain. So I'll take you through an example of how to bring those in, and they're the most straightforward. Requires very little in terms of user intervention. So if you can get them in those formats, that's going to be the easiest. The other bit that I've mentioned is about being able to bring them in as part of a batch import. So if you have these MSI files, then you can actually bring those in as into the tool as part of a site import, and I'll take you through an example there. Then I'll cover the antenna editor, looking at how do if I only have, say, an antenna PDF which just has a polar plot, but I don't have any of the technical information, in a CSV or a text file, then how do I create something from that? And then finally, I'll look at the antenna database. Okay, so first of all, we're going to look at just bringing in a standard MSI format antenna. So I've got this one is actually ICS Telecom I've got, but if you have ICS Design or HTZ Warfare, then in this case the process will be exactly the same. So I'm just going to look at one of these stations. Okay, and it's the patterns tab that I'm interested in. Okay, so initially I'm going to look at what's called these 2D antennas, horizontal and vertical, and I've got on the right hand side here these 3 dots. So these are the standard formats that you can use. So these are to say the easy formats, and we'll come on to look at some of the others in a moment, but I'm just going to start with this MSI format. Just going to navigate to the file. Okay, so I've got an MSI file here, so this has just been provided by an antenna manufacturer with the data. I load that here, and what you'll see is that the horizontal pattern is shown here on the left, and then I have the vertical pattern on the right. So it's picked up all that information from the source data file, and it also picks up the gain that's entered within there as well. Okay, so in not all of the cases that I'm going to show you will the gain be picked up, but for these types of MSI, PLT files, then you'll get the antenna pattern and the gain. So you can see that immediately that's the easiest way of doing it. I've literally selected the file and all that information has come in, so it's nice and quick. Okay, I could also do the same, and it would be the same process with the PLT with an ADF file. So if you have those in those formats, again, just select the file and then bring it in. Now, what I'm also going to show you is so-called kind of 3D antenna. So I have a PLT, in this case a 3D PLT, and the difference between the files, typically the 2D PLTs will be slightly smaller in terms of size, and if you open them up as well and look at them with some sort of text editor, you'll see that the 3D ones, as they're referred to, are an array of values, whereas it's just a couple of columns for the 2D. So if you're not sure, have a look at the file. If you try and load, for example, if I went back to the 2D here, and then for this 2D PLT I was trying to load a 3D PLT, then I would get a bad format message. Okay, so if you're not sure, then typically you'll find out very quickly whether you've selected the right format in order to bring them in. Okay, so I'm going to use this 3D format here. Okay, so the menu's now changed, and I'm going to import one of this PLT in a 3D variant. Okay, so I've brought that in. You'll see that again the antenna patterns have come in here, both the horizontal and vertical, and I've also got the antenna gain. And you'll see this little window here that's popped up, which is a 3D kind of representation of the antenna pattern as well. So that just gives you a kind of a 3D perspective of that antenna pattern. Okay, so again, straightforward in terms of the way you can bring the data in, but obviously that was a so-called 3D one as opposed to a 2D version. Okay, so those are typically the easiest if you're able to get hold of these PLT or MSI or even ADF files, then very little to do. But unfortunately, often life isn't as easy as that, and we don't get all the information in a nice one-click, easy-to-import format. So I'm just going to take you through how you could bring in some data, which is quite common in terms of that might be provided to you. So I'm just going to load up here a source data file. So this is just for an antenna file. So I've stripped out some of the other information, but effectively what you have is and this is an elevation I'm looking at here. So you have an angle here, and then a gain value in this column here. Okay, so this is just a source data file that I've been provided. As I say, I've just stripped out some header data here. Okay, so that's just the one here, and then I'll show you the similar one in the azimuth. Okay, so again, angle and then the gain. Now the trick then is to actually what the tool is expecting. So I'm just going to scroll down to where the 0 is. So the tool is looking for the form of the antenna pattern. So in actual fact, what we have to do is find in here the maximum gain and subtract that from all the values. So effectively, your point of maximum gain becomes 0, and then all the others are, X dBs below that maximum bore site gain, effectively. Okay, so it's a little bit of manipulation in Excel. Initially, when you're saving the file, then you either have to save it as a space or tab separated, so not a comma separated. And I've got there's a PRN extension which is actually a space separated, so that's an option within Excel, for example, to save it as that. So provided you take the maximum gain away from all of the values, the maximum then becomes 0, all the others become a dB below that, and then you save it as either tab or space separated, then that will give you in a format that you can consume within the tool. Okay, so I'm not going to show you the actual Excel bit here, but I'm obviously just going to take you through the import. Okay, so I've got that input file that I've taken, I've created here. So how do I bring that in? So I've got the two pattern information here, the horizontal pattern and the vertical pattern. And under this import.dia, I have the ability to bring in, I'm just going to do a view on all the files. So these are the files that I showed you, and I've saved these as a space separated. So I'm going to just load the one up here. So this is a 90-degree sector antenna. Okay, so you can see here then the form of the pattern that's been brought in from that input data. I can then go through in the same way, but for the vertical. Select the vertical pattern. In this case, this is one that I've classed as elevation. Click OK. So again, you can see the visual representation for that here, the horizontal pattern and the vertical. And then the difference with this is that you don't have the overall antenna gain that's being pulled in, so that's where you'd have to enter the maximum gain of the antenna into the system here. Okay, so it's the form of the plot that we've brought in here. Okay, so that was looking at MSI and PLT initially, and then the CSV initial input that I've turned into a space separated to bring in the horizontal and vertical information. Okay, so just stepping back to the presentation just to see where we are. Okay, so that was, as I say, bringing in some kind of standard formats and then some antenna data that needs some manipulation but can still be relatively easily brought into the tool. And I'm going to look at batch imports next via this ASCII import. Okay, so I have the generic ASCII import. And what that allows me to do is bring in site data, that sort of thing. So I can load up. Certainly, first of all, I'm looking for the source antenna data, which has to be in a certain location, and then the source file for the file to import. So I've got the file to import here. I'm going to load this ASG file, which is the so-called header file. So this tells me how it handles the columns of data. Okay, so I've entered here call sign, X, Y, azimuth, antenna height. But the key one to mention here is this extra column here, which is antenna name from the drop-down list, and this one contains the antenna pattern information. Okay, so what that means is that when I bring in my station data, so position plus these other technical parameters, I can also bring in the antenna patterns at the same time. So where do you have to store these? Well, the key bit here, if I just highlight this here, is actually to store it in this location that's mentioned there. Okay, so that's in this antenna base antennas folder. Okay, so providing you have the source data in there, so this is the antenna files, then when I do the import onto the map or into a station database, it will bring all those characteristics in and also associate the antenna patterns with them. Okay, so I've got the source data file that I've here with the files to import. I've located my MSI files in this base antennas folder, and I'm just going to bring these onto the map now. Okay, so let me just zoom in. Okay, so these are the stations that it's brought in, so I'll just go in and have a look at one of these. Okay, so on the patterns tab now, so on the general tab, then I have all the information about the power, the antenna gains, frequencies, all those sorts of things that I've initially imported. But I also have the antenna pattern data that's come in here, and because it's an MSI file, then it's populated again. So it's a nice, easy way of bringing in all of that station data and associating the antenna pattern with it all in one go. Okay, so that was looking at batch importing via an ASCII file. Now, I've already mentioned that you may not have these MSI PLT formats. You may have some CSV files or some text files with some, angle and gain data. But in some cases, you may not even have that. I had a project recently where somebody had some antenna data, which was basically just a PDF, and I'll actually show you that in a second. And they said, okay, I don't have any values for this. Is there any way we can still use that within the tool? Okay, so that's what I'm going to take you through now using this antenna editor. Okay, so firstly, I'm just going to bring up the antenna data sheet that was provided. So this is for a FM broadcast, so it's a dipole antenna. So basically, this was the only information available. So just the polar plot you can see here with the horizontal and vertical information, green in the horizontal, blue for the vertical. Okay, so there's no associated columns of angle and gain that was provided. Okay, so how do we actually bring that data into the tool? Well, we can use it again via this edit H pattern, but instead of importing or bringing some in, we can actually input some values in here. So I'm going to firstly just delete all, so just start from scratch. I'm going to put an increment here, so this is an auto increment of 10 degrees, so I'm going to take a value every 10 degrees. And I'm also going to change this to a percentage, so there's the three options there, either dB percentage or dB linear. Okay, so depending on what the format of the data is, and in this occasion there was some data that relating to a percentage. Okay, so I'm simply going to enter in some data here. I just click enter. Okay, so those ones are initially at 100, and then I'm starting to enter some values in here. So you'll see the form of the pattern that's taking shape. Okay, so I've just quickly entered those values in here. So I've gone between 0 and 180 initially. The nice thing is there's some symmetry bits that you can do here. So if I look here, so I'm looking for source data here. So I've got these in kind of my right-hand quadrants on here. So this bit on the left is saying where's the source and how do I want to then provide the symmetry. So I'm going to click on this one to effectively reflect it around that y-axis. And you can see then the sample that's given there. If I click OK, and you can see the form of the antenna pattern that's been generated. Okay, so just showing you, and I'll just bring this over here. Just make that a little bit smaller. Okay, so you can see that the form of the antenna pattern here, so this is the green one on the left, and then obviously this is the one that I've entered into the antenna editor on the right-hand side here. Okay, so that was for the horizontal. I can do the same for the vertical. So I'm going to go in 10-degree increments again. Okay, so I can enter in the values there. In actual fact, I should have changed that to a percentage. So let's do that again, because these are percentile values I was looking at. Okay, so that's now looking a bit more sensible. Then I have again the option to do symmetry as I did before. So this obviously is the source one in this sort of top right quadrant. Click OK, and then again you can see that the form of the antenna pattern matches that, albeit this is kind of rotated so that this is kind of the zero along this sort of easterly along here. So this form of the pattern is the same. If I just bring that up again, so you can see here, this is the same as the vertical one here, but just obviously rotated in terms of this is zero along here rather than sort of north in the PDF.
Well, I've got a question that's come in.
Yes.
The question is, it's well known that if mounted on a tower leg, omnidirectional antenna patterns are distorted and are no longer circular. Is it possible, using ATDI tools, to see the effect of the tower legs on the omnidirectional antenna pattern? So that's whether it's possible to see the effects of the tower legs on the omnidirectional antenna pattern.
Yes, it is. I mean, there's a couple of options there. I mean, it can well be that you've got some data you can bring in almost in the same way as I've got here, or we have Antios, which is a kind of a separate tool which you can use effectively to model that situation where you've got things mounted on a tower and get the antenna pattern in a format that then you can just bring into ICS telecom design or warfare. So yes, that is possible.
Okay, thanks for that question, Janko. I hope it answers enough for you. Thanks, Paul.
Okay, so that was using, as I say, the antenna editor, as it's called, to bring in just a pattern data. And again, obviously, you have to just do that visual comparison between the two because we haven't got any measured data. But you can see there that, and in that case, it's a relatively straightforward antenna pattern there. But if it's a slightly more complicated, then it's just a case of reading off some values and inputting those into the tool. You can change the increment size, so it doesn't have to be 10 degrees. It can be obviously, whatever's most appropriate for the antenna that you're trying to bring in. It's less preferable than the other formats because it's more work to do. But as I say, in some cases, and a recent project was an example that it may be the only thing that you have in that respect. Okay, so that was covering the antenna editor. I just want to then mention about the antenna database next. Okay, so you've got some antennas, perhaps you've imported and you want to store them in an antenna database. Okay, so where are these stored? So if I have a look under this database library, I've got the antenna database here. If I click on list, okay, so this will show me the antennas that I have already within my antenna database list. Okay, so if I want to add one of these, and then I'll just call this one sample. I can enter a description here, so this is going to be the name to help me identify it, and I'm actually going to bring in let's just have a look here for and then I'm going to bring in the vertical pattern as well. Okay, I seem to have confused it. I think I may have tried to enter something in the wrong place. I'll give it 30 seconds just to see if it recovers. In fact, I'll close that and start that again. Okay, so I think in that case I was trying to load something incorrectly. It may, as I say, it may well have kind of got there, but rather than waiting, I'll just reload the project up here.
We have got a question while we're waiting for that one to come.
Yep,
How do I
okay.
view and modify antenna PLTs in 1 degree resolution, 5 degree resolution seems to be the minimum ATDI uses. So that's how to view and modify antenna PLTs in 1 degree resolutions. Keith's saying that ATDI solution currently only uses 5 degrees.
Okay, and this is for PLT files, is it?
Yes, it is.
Okay, well maybe we'll take that one a bit further towards the end, if okay, because it's not a 30-second answer, but it is possible basically to do down to 1 degree with those let's call them the standard types of antennas. If you've got other more microwave ones, then you can go below that in terms of resolutions. Okay, so that was PLT 1 degree resolution.
We'll pick that one up at the end, Keith.
Yep. Okay. So coming back into my library, the antenna database. So I'll just add a sample one again, and I'll pick this MSI format one. Okay. So again, that's picked up the antenna description in this case. So the name of that. So again, this is coming from the source file, the gain of the antenna. I click OK, and it happens to be obviously the same one as a sample one I've added previously. So you can go along and then populate those antennas into the database. Okay. If I'm then selecting, so let's go down to some of the stations here. Okay, so on the patterns tab, then I have the ability to go into the antenna database. So this is just another view on that same data that I showed. Obviously, you can then double click on it and it will load up this antenna pattern. Obviously, this one has an azimuth direction specified in here. So this allows you to have, the antenna database, a library effectively of antennas that you can then choose from once you've imported them initially into the tool. Okay, you can actually change the location of these if you want. So by default, they're stored in one of the application directories. But if you change this library, so under this, they're all stored in this kind of ICS telecom, in this case for me, base directory. If you change the location here, so it could be you've got a shared one somewhere on a network server or something. So if you want to all access it, then you obviously just have to get this location to point to there, and then those files will get stored in that location rather than this default one here. So there's a flexibility there to specify where you're actually storing those antennas. Okay, so that was looking at an antenna database and actually populating and then being able to use those as well. Okay, so I'm just going to talk a little bit now on just patterns, gains, which we've touched on already, but just to to go through just a couple of bits, just to re-emphasize a couple of points which are important. Moving on then to antenna reference and looking at tilt. Okay, so I mentioned this briefly earlier, but the thing that is important is the antenna pattern data. They're points, so they're treated as losses compared with this maximum gain. So it's the form of the pattern here, which is the important bit, and then we either automatically, if it's via say an MSI PLT file, have the gain applied, or we have to manually enter it into the station parameters. Okay, so the pattern, as you can see here, losses relative to the main bore site, and then the gain is entered separately. Okay, in terms of antenna reference, then there's a couple of different options here that I'm going to mention: isotropic and dipole, which are quite commonly used, and I'll also talk about height reference. So what is your antenna reference to in terms of is it ground, is it something else?
Well, I've got a question here about
Yes.
antenna reference. Where do I enter the polarization for the antenna?
Okay, so let me just step into the tool again. So I'm going to bring up the patterns tab that we had before. Okay, so that's obviously where we had the antenna pattern information being populated. If we're manually adding the gain, we're adding it here. For the polarization, then that's over here on the left-hand side. So whether it's vertical, horizontal, or the other, circular mixed polarization that we've got here. So that's where you'd enter that within the tool. Okay, so that's as I say with the height. With the antenna polarization and antenna gain. If I want to set these, what are they referenced to in terms of my antenna patterns, then over on here on the thresholds, and I've got the ability to choose between these three here. Typically, probably the dipole and the isotropic are the most widely used, and that means then that my gain, so if I set that to isotropic, if I then go back and look here in the station parameters, you'll see this is a dBi value, so reference to an isotrope. If I go and change this to a dipole, and then go back into the same station parameters, you'll see this is now dBd. Okay, so reference to a dipole antenna in that case. Okay, so that's looking at different references as I was referred to, but you also have reference in terms of what is your antenna height reference to, and those can be set under these clutter options. So I have whether it's, and this is both for transmit and receive, so transmit here on the right hand side, receiver on the left hand side. And it's generally whether it's referenced to ground or clutter. So I can choose what my antenna height. So when I specify in the station parameters 5, 10 meters, what is that reference to? Is that reference to ground level, or is it reference to clutter? And clutter often is perhaps where you've got some some buildings data in that sense. If you're interested in understanding a bit more about that, one of the recent webinars on clutter covered this amongst other things in a fair bit of detail. So I'm not going to cover anything further on that today, but perhaps have a look at that previous webinar if you're interested in finding out a little bit more about that. Okay, so that was looking at antenna references. I'm just going to move on to tilt now. So this is the different types of tilt that you can have within the ATDI tools. So mechanical is perhaps the easiest to understand. So physical, kind of tilting on a bracket on a mast. You can see here that the kind of, let's say that down, this is our kind of main lobe coming down here, and then the net effect of a down tilt in this case is that you push the back lobe upwards. So you can see here on the right hand side that this is kind of trying to give you a representation of the polar response of the antenna pattern. But obviously that mechanical tilt does actually change, both let's say this front and then also the back lobe as well. There's also the option to specify as tilt in electrical. So this is kind of settings within the antenna, being able to change the phase supplied to the antenna elements to actually give you this electrical tilt rather than it being a physical mechanical tilt. And you can see here that the difference, so the main lobe here, but then the back lobe also, so around this kind of 360 is also tilted downwards as well. So obviously the two different types of tilt, and you can specify those. There's also rotary tilt with really radar systems in mind, but I'm not going to cover anything more on those. But those are the three options within the tool, and I'll show you where to set those in a moment. The other thing, just to alert you to, is that the convention used is for positive above the horizon, negative below. So if you're specifying a down tilt, then you need a value in here that's a negative. So it's 10 degrees down tilt is a -10 in terms of being able to input within the tool. Okay, so let me just show you where you can set those. So firstly, under the preferences menu, you have the option here to select the types of tilt. So this is kind of on a global basis, so mechanical, electrical, or rotary. Or you can, if you set them individually in the stations, you can choose this from TX parameters. So those are the options there. And then when you then apply a tilt, so if I go into a station and apply a tilt here. So let me just load up one of the antenna patterns, so I've not got an omnidirectional, and then I provide a tilt value in here. Now in this case it was a mechanical that it's referenced to, but you can see there that obviously this is tilted, so this is kind of 0 on the horizon. I put -10 in, so it's giving me a down tilt of 10 degrees. Okay, so that will then be taken into account when you're running a coverage prediction. Okay, so just as I say, positive above, negative below, and then it should be absolutely fine. Now some people perhaps have a down tilt being a positive, but it's positive above and negative below here. Okay, so that was on tilt, and then the last thing that I'm going to cover is just about making some batch changes, the inbuilt antenna library, and then obviously using one of the patterns that we've imported this morning just to actually go and predict a coverage. So firstly, batch changes. So I'm just going to initially just in my station list here isolate these stations. So I'll do these ones. Okay, so I'm then going to make a change to the antenna patterns here. Okay, because I've perhaps brought in some station information, frequencies, powers, that sort of thing, but I haven't applied an antenna pattern already. So under this object, change antenna, okay, I have the ability to change the antenna. Again, I can access my antenna database. So if I want to use the one that I've just previously brought in, again, you get the horizontal and vertical patterns displayed here. The thing to look out for here is this checkbox here. So there's other parameters which you can change, but in order to apply this pattern, so if you're making a change other than a pattern, then this is normally checked. But to avoid you inadvertently doing it, you have to say uncheck that. So that will then apply this antenna pattern to all those antennas, okay, with the antenna gain. And if I had, I wanted a batch change tilt, so I could do that from within here as well, azimuth as well. So any of those kind of parameters that you can change that are available there, you can change. Okay, so that has gone through and then made a change on those. Now, one nice way of being able to kind of see instantly whether a change has been made in terms of a vertical, a horizontal pattern, and also any azimuth involved, is just to display these here. So this is under the object menus, and what that does is it gives me a representation of the antenna pattern. So just perhaps to make it a little bit easier for you to see, I'll change the color of that. Okay, so you can see here that the form of the antenna pattern for this is the horizontal pattern here is shown, and I've got this arrow that points for the azimuth direction that's been applied to these as well. So I hadn't changed those, this just happens to be the directions that are already applied. But it's a nice, particularly if you started with omnidirectional, it's a nice way of visually being able to see, and that if you've got multiple sectors on here that are equally applicable, that you've made that change, and that's obviously taken for all of those stations that you're interested in. Okay, so that was looking at, yes.
Sorry, apologies. I know you're just about to move on, and it's probably
that's okay.
You're going to move on to. Can I add an RPE antenna to the library?
Yes, I'm just going to come on to library. So somebody's obviously chomping at the bit for the library information. So that was batch changes and antenna object display. So I'm just going to talk about the library. And the question was about adding an RPE antenna.
That's right.
Okay, so let me just take you through. Okay, so in terms of the library, so what information have we got? So I'm just going to take you through here. So we have under this antennas, so it's in the application directory. So there's some kind of sample ones here, mobile as their class. So you can see there's a number of manufacturers, and then obviously there's some bands here. So typically they'll be in this MSI format, so exactly the same way as when we brought one of those into the tool. If you just select one of these, it will pick up all the antenna pattern and the gain information. Generally, the naming convention will follow the name of the antenna manufacturer, so it should be fairly easy to make a correlation between the two. There's not every type of antenna here, obviously, but it is a starting point. It may be something that's very close to the antenna that you've got in the form of the pattern, and maybe with a gain modification, that's sufficient. But it's a nice, as I say, it's a nice starting point, and it may well be that the antennas you're interested in are already here. If not, go through one of the kind of importing processes that I've already outlined this morning. Okay, for RPE antennas, so these have their own directory here, base RPE, and I'll perhaps just show you on the microwave a microwave station, perhaps just to view the antennas. But you can see they're located here again, a number of manufacturers' antenna data. So let me just take you into the microwave. So I've got a couple of sample microwave links here, so I'm just bringing up this one, and then I've got the patterns tab. Okay, so these 3D RPE files as their class. So this is basically just another view on that source data that I was showing you via a Windows File Explorer. So if I look in here, so this is all the antennas that are in the database here. And if I click on one, obviously you can see a bit of information about the antenna gain, and then you get the patterns that are displayed here. So just clicking through the different ones, you can see obviously the actual, and this is HH, HV, VV, and VH, so different combinations that make up this kind of 3D RPE antenna data. Okay, so these are the ones that are here already. If you want to add, and this obviously assumes you've got perhaps the correct format already supplied in the data, then you can add into this list. So I'm just going to take into, say, this Andrew one, and I'll bring up, I think I've got a sample one here that I can use. Okay, so let's have a look under this antenna samples. Okay, so I'm just going to take this, so this is this ADW format, and I'm just going to paste this into this directory here. Okay, so you can see the name that I've given there. Okay, so that will then become available to use in the tool, but the only thing you'll have to do is there's this little button down here which is rebuild the index file. So if you see at the minute I've got this 6913 antenna, but if I go in and rebuild the index file, so this basically looks for any kind of changes that have been made. So in the case where I've added an additional RPE file to it, then that will go through and then be displayed in the list. Okay, so that's that file that I've just copied into that directory, rebuilt the index, and you can see that that's now there available to to view obviously within here, and then associate with an A end or a B end of a station. Okay, so those are the two main bits. The microwaves are probably slightly more extensive than some of the mobile and other types of antennas, but there's quite a lot already there. I think most of the projects we've worked with, certainly with the microwave, then there's been, if not the actual antenna, something that's as near as as matters not to the actual one that's being used. Okay, so just moving briefly back to the presentation. So that was looking at batch changes, the antenna library being able to populate an extra one in there, and the antenna object display. And I'm just going to lastly just show a coverage prediction just with those three stations that I have there with some directional sector antennas on. Okay, I'm just going to isolate these. So effectively all the stuff we've done so far has been preparation for being able to use these antennas. So I've imported these. So this was this sector antenna based on the MSI import, and then I can run through and just run a coverage prediction here. So I'm going to do that, and I'll set this out. Okay, so this is just going to go around now, predict each one of these in terms of a coverage. You can see here in this case I've got the, it's not a rectangular calculation limit I've got set. So run through each of these, and then obviously at the end of it we'll see that we've got the form of the coverage that's based on this this antenna sector pattern. So it's not an omnidirectional. In this case we've got an antenna pattern that's applied with the gain that's been picked up, because we've used that MSI file. So we've got the antenna pattern and the gain that's picked up. Obviously any tilts that we've applied to it that are we've input into the tool. One thing perhaps just to mention at this stage is that just be careful with the tilts, because often you'll find, particularly with the electrical tilts, that they have antenna patterns with this information built in. So don't obtain that with, say, an included 4 or 5 degrees down tilt, and then add an extra tilt into the station, because you'll effectively be kind of double counting, as it were. So that's done. Let's just isolate one of these stations and have a look at it here. Okay, so you can see, if I just zoom in, obviously the majority of the in this case energy is being concentrated off to the east. So that's the azimuth that I've got in here. So there's less in terms of that. And obviously, if I had multiple sectors on this, you'd see a kind of a sector configuration in terms of the coverage there. But that's all that stuff that I've shown this morning. The import, being able to configure, is really all about how do I get it in the state that I can then use it to predict coverage within the tool. Okay, right. So questions. So any questions? I know we've got the one about the PLT files. Is there any other questions about anything you've seen this morning?
Yes, we've got one that just needs picking up again, and that was about the modifying antenna PLTs from 5 degrees to the 1 degree resolution, Paul.
Okay, so let me just have a quick look in here.
If anyone else has any other questions, by all means, put your hands up and I can unmute you and you can talk to Paul directly. Otherwise, you can use the questions toolbar as we've been using throughout this event. Okay, so so what have I got here? So this is a sample PLT file. This is actually something that Nick used on one of his other webinars recently, but it just shows the format of the data that's within, say, these PLT files. So if you've got there's a value here which specifies a number of values. So as long as you've got these 1 degree intervals specified, then that should be fine. Obviously, if you're editing within here, then this value needs to match the number that you've got. So the format of these is very specific. So if you tell it 270 values and you actually got 360, it's going to cause a problem. So just make sure in terms of that the syntax is correct. Again, it's a similar idea. In this case, we're talking about a space separated, a space delimiter. In this case for these PLT files, but it's the same for these MSI files. I actually had somebody else that sent me some antenna patterns in this PLT format recently, and it wasn't being accepted correctly into the tool, and it actually turned out that the gain, this word, so it's very specific on syntax, was actually in lowercase, and that was, or sentence case, and that was actually causing the problem there. So it's very specific in terms of the antenna formats that it's expecting for these PLT MSI, and providing you have that in the correct format, then it should go in and read it okay within the tool. Okay, does that answer the question? I mean, certainly in terms of editing or viewing, I'd suggest probably Excel or some other text editors probably is the best way of being able to see what that source file has before you try and do something with it within the tool. If you just give me a hands up on that, Keith, just to let us know that clarifies your question. Yeah, that's brilliant. Thanks for that, Paul. That's lovely. Do we have any other outstanding questions? So anyone else have any outstanding questions they'd like to put to Paul? While we have been on today, I have actually managed to send you 2 downloads. These are the handouts, the brochure for Antios that Paul made reference to earlier in the day, and an example of Antios, which is a PowerPoint presentation. They are both quite old, but the project is still marketed and available. If you're interested, please do contact us. Just while we're waiting for any last questions to come in, as I said previously, you will receive a survey. Feedback from today's event is really, really helpful to us, and we'd appreciate just 2 minutes of your time to complete that. The invitations will be coming out straight after we finished. Do sign up. The places are limited, and obviously, as you've attended today's event, you get an early bird option to attend the next event. I think that's about it. Let me just check to see if we've got any last few questions.
I mean, the only thing while I've got this up, Sarah, is maybe just to mention that I kind of briefly said that. So for these are I'm going to class as more standard antennas, PLT, MSI, typically associated with wide area coverage. But there's also the RPE antennas that will actually allow you to to have a. You can see here in terms of the values that they're not. It's not integer values, and so it's not 1 degree minimum. So these will take down to kind of 0.1 in terms of the spacing there, because often they're very narrow beam width. So just being able to specify a 1 degree interval is not sufficient. So in those cases you can go down below 1 degree, but in most of the other mobile wide area coverage situations, let's say, then 1 degree is typically absolutely fine. So.
Okay, that's lovely, Paul. We don't have any further questions. I'd like to say thanks, Paul, for presenting today. Much appreciated. Thanks, everyone, for taking the time to join us. I know it's a busy day because it's a short week for a lot of us, so we do appreciate that you've made the time to come today. Do register for the next event, and we look forward to joining us soon. Thanks a lot, everyone.